This first video is going to be a continuation from our notes from day 3.4, finding the zeros, and we started to talk about how we can use test results to try to figure out which numbers we should be plugging in to figure out how we can get our factors here. So the way that we get our P and Q, as a reminder, is that for my P values, I was looking at my constant value here, this -6. And when I take a look at this -6, I start to list all of the factors of it. Factors of -6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. For my Q value, I'm looking at my leading coefficient, which in this case is just a +1. So therefore my factors of Q are going to be plus or minus 1. To get my test results down here that are listed already, my test results we got were plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And to get that, I'm just dividing my P values by my Q values. So our goal here, and what we're actually going to be doing here, is we are going to be using synthetic division, and we are going to be looking for a remainder of 0. If we do synthetic division with one of our possible test results here, -1, -2, any one of those numbers, if we're able to go through and get a remainder of 0 when we do synthetic division, that means that the number we have chosen to use is a factor of the given polynomial. So if I was to take a look at this, I could start off, and let's say we picked off -1 as an example. So if I did synthetic division, I would set it up, and I would say -1 with my chart here. And remember, with synthetic division, you're just pulling the coefficient from each one of your terms. So the coefficients would be 1, -1, 1, -3, and -6. So I'm going to bring those right on down here. So I get 1, -1, 1, -3, and -6. I'm going to bring my first term down and get -1 times 1 is -1, and we are adding. So I get a -2. -1 times -2 is a +2, which gives me 3, -3, -6, +6, and 0. Because I got a 0, it checks out, and it means that -1 is indeed a solution or a root or a 0 to the given polynomial function. It also means that what's left, this quotient, is a factor as well. This quotient can be translated into this. And notice how I work my way backwards so I get all of my exponents correct. So right now, x cubed minus 2x squared plus 3x minus 6 is a factor of our given polynomial, x to the 4th minus 3x plus 2x squared minus 3x minus 6. And so is what we found, this -1, which remember will translate to an x plus 1. Now we can continue with this process and now try to find another factor for our new polynomial function right here, this x cubed function. So to do that, I'm going to set up another synthetic division problem. Using my same test results from the original one, we could try 2 this time. I'm going to evaluate this function in red, so we know we're dealing with the red function now. And I'm just going to go ahead and I'll say we'll test for 2. And for here, I'm going to use my coefficients from the polynomial, our new polynomial function. So we have 1, -2, 3, and -6. From here, I have bring down my 1. So I get 2 times 1 is 2. This gives me 0. 0 times 2 is 0, which gives me 3. 3 times 2 is 6. -6 and 6 is 0. So again, we have another factor. So we now have a factor here. This was our factor. -1 was one of our zeros. And now we have another 0, 2. So what I'm left with now is this. This is my new quotient that I'm left with, my new polynomial that I'm left with. And to translate this, it becomes x squared plus 3. Now when you go to solve x squared plus 3, If you set that to equal to 0, you start by subtracting 3 from both sides, and you get x squared is equal to a negative 3, which will give you a complex solution. Because we are only looking for rational zeros here, the only two rational zeros for this given function, x to the fourth minus 3, or minus x cubed plus 2x squared minus 3x minus 6 are going to be negative 1 and 2. I could also rewrite this given polynomial as the product of its factors, and I could rewrite it like this: f of x is equal to x plus 1, x minus 2, and x squared plus 3. This again is our real solution of positive 2, and then our last two complex solutions, because it's plus or minus. So we have a fourth root polynomial with 4 solutions, 2 real and 2 complex. You also can look at the graph to see this information as well. And you can see here are our 2 real solutions listed at negative 1 and positive 2.